Okay, so in this video, I want to basically do some percentage problems that are very like the ones you will face in the content assessments. They're just different numbers, but they're same kind of skills. So what I advise you to do is to pause before I do each one and try it yourself so you can take advantage of the practice. The first type of problem I want to talk about is percent increase. With percent increase problems, my hint is that you actually do not use the new value in your calculations, but the difference between the original value and the new value when you try to figure out the percent increase. The reason for that is apparent when you look at that diagram that I taught you guys to do in other videos. In this first problem, for example, pause it before you try it. Okay, you can see that the original value is 82, which is matched, of course, then with the 100%. Now, I'm going to increase this by a certain percentage that I don't know what it is, and I want to find out. I do know that the final value is 110.7. The issue is, if I use this new value in my is of setup, I'm going to end up with the new percentage, not with the percent increase. So remember, is of setup, by the way, is that idea of is of, and remember the is could be part and the of could be whole. The is could be new, and the of could be old, right? But you always make that equal to the percentage over 100. So if you try to do that in this problem, you put the equal sign, you put the fractions, always start with the percentage, look for the percentage in the problem, but in this case is what I'm looking for, so I put an X, then I put the whole, which is 82, and then it becomes the issue. If you put 110.7 up here, then when you get your answer, it's going to be off by 100 because it's not going to be the increase. It's going to be the increase plus the original 100. So you would have to remember to subtract 100 if you do it that way. So the way I like to do it instead is to actually figure out what this gap here, what is the increase? Well, you can just put that in the calculator, 110.7 minus 82, and you would get 28.7. And if you put that 28.7 up here and you continue doing the work that you're supposed to do, cross multiply, divide by what's next to the X, you will get an answer that is directly the percent increase. So if you actually match the increase, you will actually get the percent increase. But if you use the new value, you get the new percentage, and then you have to subtract 100 from it. So let's see the answers for this. So again, if you use the 28.7, and then you cross multiply, you would get 82 times X, which is 82X, and then 2870 times 100, which makes 2,870. And then you divide by 82 both sides, because that's what's next to the X, and you got to get rid of it. And then you get an answer that's 35%. Now, again, remember, if you had used the 110.7 up here instead of the 28.7, you would have gotten 135% as your answer, and you would have to make that mental note. No, but that is the new percentage. It's just why making a diagram can be helpful. All right, so thinking about that, try the next two problems, which are on the screen. All right, these two problems. Let me erase here for you so you can see it better. And I will, don't forget the is of setup, and then pause it, and I'll reveal the answers. So here we are with the answers for the next two problems. On this one, if you figured out that the difference between the new deer and the old deer is 40, because 290 minus 250 is 40. So the deer went up by 40. That's what I'm going to use for the part because it makes my life a little easier. So I set up the diagram by doing 100 and then putting the percentage is what I'm looking for. So I put an X on top of that. And then 250 is my original. And then I use 40, which is the increased amount, as my part. You could use 290, but then you have to make an alteration at the end. When you do that and you cross multiply, you get 250x equals 4,000. Divide both sides by 250 to find out that the answer is 16%. If you had used 290, you would have gotten 116%. You would have to remember to subtract 100 if you did it that way. Next problem, same kind of idea. 840 is where it is now. It started at 600. The difference is 240. I don't know why it says 160 here. Quick correction. 240. All right. So if you use that 240 as your part, you can set up at 100% to the bottom, X on the top is what you're looking for. So then you put that percentage as an X. You start with 600. So you put that in the bottom left, sorry. And then 240 on the top, which is the increase amount. You could put 840 on the top, but then you would have to make an adjustment at the end. Cross multiply 600 times X equals 600X. And then 240 times 100 gives you 24,000. And now you divide both sides by 600 to get rid of what's next to the X, and you get 40%. Again, if you had put 840 instead of 240, your answer would have been 140%, and you would have had to make that adjustment of actually deleting the 100 out of that because it's the increase. All right, so now let's look at some percent decrease problems. Now, the reasoning is exactly the same. It is easier if you figured out what the decrease was, right? So subtract the old value and the new value and figured out what the decrease was and use that as your part. It would make more sense and make it easier for you to find your answer than if you actually figured out the percentage the other way. If you do it the other way, you would have to subtract from 100 at whatever you got. It would have been different. So try these problems on your own using the same mentality of figuring out the difference before you do the setup. Pause it, and then I will review the answers. Here's the answer for the first one. Let's see if you did that right? So I calculated the difference between 980, which is the original messages, and then the 686, which is the people that replied, to be 294. And I used that as my part on the is of setup. I started by putting 100 on the bottom right, like always. I know I'm looking for percentage, so X goes on the top right. 980 is my original, my whole, so I put it on the bottom left. 294 on the top, because that's the difference between the original and the new one. I could have used 686 on the top, but then I would have to make an adjustment. Anyways, you multiply both, cross multiply these things. You get 980 times X, which is 980X, and then 294 times 100, which is just 29,400. Divide both sides by 980 to get rid of what's next to the X, and then you get your answer as 30%. Now, if you had done this the other way, if you actually had put the 686 on the top, you would have gotten 70% instead. But then remember the idea of the setup here, okay? If you actually start with 980 and you end up with 686, all right? If you use this number, you are not looking for the actual percent decrease. You're going to find this as your 70%. Now, because the 980 is where you started with, the 100%, if this answer is 70%, your decrease is actually 30. This is why I prefer to use the difference. If you use the 294 instead, then your answer will be directly the answer you want, which is the 30%. Try the same method for the next two problems and see if you get them right. All right, so here you see the answers for those problems that were left. So on problem 2, I actually did 90 minus 67.5, and I got 24.3 to be the difference between the values, and that's what I'm going to use for the part. Then I put 100 on the bottom right, like I always do in the is of setup, put X on the top since I'm looking for a percentage. On the bottom left, I put the original value, which is $90, but then I only pay 65.7. But if I use that, I would have to make an adjustment. So I use the difference instead, 24.3. Cross multiply, again, 90x equals 2430. Have to divide both sides by 90 to get rid of what's next to the x. And when I do that, I get 27%. If I had used 67.5, I would have gotten 73% of my answer. And I would have to get 100 minus that to get my answer. So I prefer doing it by finding the difference because it makes it a little easier to do it this way. Next, I have the trader problem. Started at 225, ended up at 207. The difference is 18. That's what I'm going to use as my part, so I don't have to do the adjustment. Put 100 bottom on the bottom right, X at the top, is what I'm looking for. Bottom left is the whole, which is 225. Top left is the part. Now I'm going to use 18, so I don't have to do the adjustment. Cross multiply both sides, you get 225x equals 1800. divide both sides by 225 to get rid of what's next to the x, and you get 8%. Again, if you had used 225 and 207 instead, you would have gotten 92%. And then that is not your answer. You'd have to do 100 minus 92 to get your answer. So if you basically, for percent increase and decrease problems, if you use the difference between the old and the new value on your part, you always end up straight at your answer, which is what I would do if I were you, to actually prevent myself from making a mistake because I forgot to subtract that 100 if I was doing increase, or subtract from 100 if I was doing decrease. You're better off trying to find a difference and using that in your part. We're not quite done yet. We still have to look at other types of problems that are going to show up on this BFA. Tip and discount and tax problems are always also going to be there. So let's do that next. So tax problems, remember, are usually going to be two types. One, that you have to figure out the final cost of the meal, in which case you have to figure out what the part is and then add to the whole, or just figuring out what the tax is going to be, which is not needed to add to the whole. So the first one there, you just have to figure out the part. The second one, you have to get the part and add to the whole. See if you can figure those out. Pause it before you try it. Actually, before you unpause it, there's one more thing, a hint that I want to give you in case so you don't get it wrong. Basically, here you just have to pay attention on whether they want the final value to be including tax or just the tax itself. And that's the hint for tax. And the second hint is, remember that tax is always the part. So in these examples, unlike the percentage increase or decrease problems where we were looking for the percentage on the previous problems, this time we are looking for the parts, right? So the x is going to be the part. So with that in mind, try the problems. Okay, so here are the solutions for the tip problems. So the first one is 8.4. You're just looking for the tip. Remember, I'm not really doing diagrams for all of these, but it is helpful to do diagrams to help you visualize what's going on. But basically, I just went off straight to this is off setup. I start with 100 on the bottom right, and then I put the percentage on the top. And the percentage of here is 15%. Now I know the original value is 56, and I'm looking for the part, so I put x there. Cross multiply, you get 100x equals 840. When you do 56 times 15, you get 140. Then you have to divide both sides by 100 because you're getting rid of what's next to the x, which is 100. And your final answer is going to be 840 divided by 100, which is 8.4. Since all they want is the actual tax, you're done. That's your answer. So be careful not to add to the total in situations like that. Which brings us to the next problem where you actually had to add to the total because they want the final cost or the new cost. So how would you do that? The way to do that is, again, set up is off problem, 100 on the bottom, 15% is, again, the percentage used. 35 is the original price. What is the part? Cross multiply, you get 100x equals 525, which is 15 times 35. Divide both sides by 100 to get rid of that 100 that's next to the x. And your answer is be 525 divided by 100, which is 5.25. But that's not your final answer because you're looking for the new value. So you have to add that to the original, and you do 35 plus 525 gives you 40.25. Now remember that there is another way to do this too. You could use for your part, right, the percentage that you actually use, 115%. And that's when you try to go straight to the answer. Because if you think about it in a diagram, I'm not paying for 100% of the meal. I'm paying for 115% of the meal. So if you do it that way and you use, instead of 15%, 115%, you would go straight into your answer. But I like to do it this way. I figured out the part and I add to the original because it makes it easier to remember how to get it right every time. At least that's how I do it. But if you like to do it the other way, it's fine too. I just wanted to mention that in case you did it that way and I don't want you to think you did it wrong. Okay? So we have a few other problems to hit. This time we're going to do discounts. Now, like tips, discounts are going to be parts. However, the hint here is that you have to pay attention. Do they want the discount or do they want the price after the discount? And that's what you have to be careful with, all right? So we have two different kinds of problems there. And I want you to try them all because I'm going to solve them all after the pause. So remember, the hint is to use the actual percentage of the discount. And remember, that is a part. But sometimes you also have to figure out what is that you are trying to find after, and then you have to find the original value minus the part to get that answer. So look for words like discounted price or price after the discount to figure it out if you have to subtract from the whole from the original. If you're just looking for what is the discount, all you have to do is figure out the part. Go ahead and try it. So here are the answers for 3 of the problems. I saved one because I want to give you one other hint before we look at that one. You might want to revisit if you already tried it. The first one is trying to find out how much do you have to pay. So that is the final price. So final price means after I find a discount, I have to subtract from the original. Now, I set up an is-off problem, put 100 at the bottom like I always do. 20% is the percentage of the problem, so I put on the top right. 45 is the original value, and I'm looking for the part, which is x. So cross multiply, 100x equals 900, which is 20 times 45. Got to get rid of that 100 that's next to the x, divide both sides by 100, and you get an answer of 9. But that's not your final answer. I still have to subtract from the original. 45 minus 9 equals 36. There is another way of doing this, by the way, that is completely okay. If you realize that by having a 20% discount, you only have to pay 80% of the original price, instead of using 20% up here, you could use 80. If you use 80, you're going to go straight to your final answer because you're not figuring out the discount in that case, you're figuring out what you paid. So you could do that and not have to subtract at the end, but I like to do it this way because it just works for me. Whichever way works for you, you can do so. This last problem is the same kind of thing because you're looking for the discounted price. So you're going to put 100 at the bottom right, 25% is the actual discount in the problem, 5,600 is what you paid to begin with, and then x is the part you're looking for. Cost multiply, you get a 100x equals 140,000. You got to get rid of that 100, so you divide both sides by 100, and you get 1,400 as your discount. But since you want the discounted price, you have to subtract that from the original price, which was $5,600. And when you do that, you get $4,200 as your final price. The second one was a little simpler because all you want is the actual discount. You do not have to figure out the final price. The TV cost is $560 and it was discounted by 35%. So you put 100 on the bottom right, like always, 35% at the top because you're looking for the discount. And then you put 560 on the bottom left because it's the original price, looking for the part, x on the top. Cross multiply, you get 100x equals 19,600. Divide both sides by 100 to get rid of that part that's next to the x, and then you end up with 196 as your discount, right? Once again, by the way, on this last problem, you could have used 75% instead of 25% over here because you're trying to pay only for 75% if I got a 25% off discount, and then it would go straight to the answer. You wouldn't need to subtract at the end. Whichever way you want to do it is fine. But in problems where you're actually looking for the discount, you have to go ahead and use the percentage of the problem. You can only go ahead and use the difference between 100 and the number given in the problem if you're trying to find a final price. But I don't like to do it that way. I actually just, to not confuse me, I just use the percentages in the problem every time. And I just remind myself that if I'm looking for the final price, I have to subtract from the original if that's the case. This second problem here has a little bit of a kink, all right? Because they're not giving you the original price. They're giving you the price you paid after the discount. You paid $250 for something that was $40 off, right? So, and they want to know what the discount was. They don't even want to know the original price. They want to know the discount. So it's a little bit of a challenging problem, but just think carefully about what you're going to put in the is and the of, and then you'll be all right with it. Try that. So like I said, this last one can be a little bit tricky, especially because if you're trying to find a solution for a problem that has an inverted situation and you're getting confused, that's when you definitely pull that diagram to try to help you out. So I'm diagramming up here, but I'm really talking about this problem down here. All right, so you have a situation where you don't know the original price. Okay, you just know that you paid $250. That is what you paid. That is the new value that you paid, right? So the new value is $250, and you have no idea what the original value was, the value that's matched to 100%. All right? What you have to realize is that 40% discount is what you're reducing the price by, so you know that is a 40% reduction, right? And then think about it. What percentage did I actually pay then if I actually only had a 40% discount? I must have paid 60%, right? So this is the way it gets tricky. 60% out of 100% of that value that I don't know what it is going to end up to being 200. So that's the numbers I have to use on my problem. And you see me doing it over here. 100 on the bottom right, like always. I put 60% on the top right. And that equals a certain random number that I don't know what it is my X here. And then I have to figure out what the discount ended up to be 250. This is like saying that 60% of 100 is 250 is 60% of some number. When I do it that way, multiply both sides, I get 60x equals 25,000. Divide both sides by 6 to get rid of what's next to the x. And I get $416.67 for the original price. Now that I have the original price, I can subtract what I actually paid, which is $250, to figure out what my discount was. So your discount must have been $167.67 for you to be able to have a total of $416.67 at the end. Luckily, there's only like one or two problems like this in a test bank, so there's not a likelihood of you getting a problem like this. But how would you have to realize that you have to do it this complicated way? Because of the diagram. And that's why I strongly advise you to use one every time. All right, because it's easier that way to make mistakes if you don't use the diagram. We still have one last kind of problem that we have to tackle, which is a problem with tax. All right, and notice that they want to know how much you have to pay after the taxes. So all you have to do is figure out the tax and add to the total. Very similar to what you did with the tip. Try that problem out. Now, hopefully you remembered before you actually attempted the problem that if you're trying to figure out tax, yeah, it's a part, and now you have to put that on the top left as your X. And also that you have to add to the original value if you're trying to find out the final price, since it's an increased problem. If not, pause again and try it. Okay. Now, if you have already done this, it should be your answer. Realize that if you are trying to and I'm going to do a diagram here just because we came out of a problem when I told you that it's important to do a diagram. So I'm going to do it again to hopefully show you why important it is. So the original price is $22, and that's matched to 100% because it's my original price. Now I have an increase of 6%, and that is what I have to figure out what it is, so I can add to my original 22 to figure out what the new price is, which is what I'm actually looking for. Alternatively, by the way, I could use 106%, which would be 100 plus 6% in the problem, and I would go straight to my new price. Remember, if you use this percentage, you get this number, and then you have to add to the original. But if you use that percentage, you go straight to your answer. It depends how you want to do it. So I have both solutions shown over here, but 100 on the bottom right, because it's always what we start with. 6% is the percentage in the problem. 22 is the original. X is the part I'm looking for. Cross multiply 100x equals 132. Divide both sides by 100 to get rid of what's next to the x. You get 1.32. But because I use 6%, what I found right now is just the increase. So I add that to the original to get my actual final I have to pay $23.32. Alternatively, if I had used 106%, I actually would have gotten straight up into my answer of 23.32. And that's what I mentioned when I was talking about the discount or the percent increase. There's other variations that you can do the problems with, and I wanted to show you that at least once. So that is it. That is all the practice of all the kinds of problems that you will see in the content assessment. And I hope that this is clear to you. If not, I'm available during office hours, so you can reach me by email, or you can try to come see me, and I will help you as much as I can. Thank you, guys.